I got a good picture of them.
Is that a couch? That's a saw.
I saw things for diving. So, yeah. I would love it. That might be the tail.
Those orange lips are rock stars. There you go. And look, there's some.
Starfish.
My cats want to eat you. Mary's right there in the corner. You're taking the bait. Get it? That guy's skin is a triangle. This guy's just
Here in the U.S. waters, we catch swordfish in the ocean regularly. The only problem is most of these big boys are imported from places around the world. Nearly all imported swordfish are caught with long lines. Miles and miles, threaded with thousands of hooks that don't discriminate between a big old swordfish with anything else that just happens to swim on.
He's still looking at it.
are called white. Why are they called sea leopard? That one is called ninja.
Oh, is it? That's not good. Well, they get they tricked out and found the guy's body. No.
But they know where to stop.
They know where to open.
That part gets like
Let's get an octopus like this. Look at it's a shrimp. Oh my god, wait, those are different. They line up, they line up. They line up. Look, how
That's so cool. They light up.
Yeah, look at them, how tiny they are.
Where loads?
That's jellyfish. They're really teeny tiny ones.
What's this?
It might just be food for them. That's a bigger jellyfish.
Gill there.
Orange, good job. Crystal jelly.
Greek, but translated to Latin. Excuse me, sir. Crystal jelly. In Greek, but translated to Latin. Excuse me, sir.
smaller impacts, like pollution, overfishing, and possible climate change, might be upsetting the ocean's natural balance too, affecting gems and many other ocean animals.
There were 3 spider crabs.
Plankton. Trillions of tiny plant-like plankton called phytoplankton help provide the earth with much of the oxygen we need to breathe. But what if I told you these micro marvels also help protect us from some of the worst impacts of climate change? Just like plants on land, phytoplankton photosynthesize. Doing so produces oxygen and absorbs a large portion of the carbon dioxide we emit when we burn fossil fuels. And on top of all that, phytoplankton are the base of the marine food web. They're kind of essential. These little plants, they're eaten by slightly larger animal plankton, which are then gobbled up by schooling fish. And trust me, everyone, from tuna, sharks, seabirds, even giant whales. More than happy to make a meal of sardines and anchovies. It's incredible to think all life on Earth, underwater and on land, is completely dependent on this healthy, thriving community of phytoplankton. Now we know a lot about how life works in the sunlit, shallow waters, but most of the ocean is cloaked in darkness. Researchers have been trying to overcome the crushing pressure, profound darkness, and frigid temperatures that have limited the study of the deep sea for a long time. All starting in 1934, when scientist William Beebe teamed up with engineer Otis Barton to make a series of historic dives off the coast of Bermuda. After being bolted into this thick steel ball, the bathysphere, Beebe and Barton were lowered a half mile beneath the surface. It was dark. All they could hear were the unnerving creaks and groans of the sphere as it descended. They hoped the vessel would withstand the immense pressure without crushing them inside. But when Beebe peered through that tiny window in the bathysphere, he saw the strange glowing creatures they call the deep ocean home. Creatures like the black sea devil anglerfish that use a glowing lure to attract curious prey have always fascinated ocean scientists, keeping them eager to understand the secrets of life in the deep. Those first dives, they started a new age of ocean exploration that sought to shed light on this incredible underwater world, previously completely impossible to visit. Now, lucky for us, this legacy of exploring the unknown, it gets to continue today. But we have a lot to learn, because the ocean happens to be massive, and it's really hard to study. Of course, that started to change in 1984, when Silicon Valley tech pioneer David Packard funded the Monterey Bay Aquarium. He understood the importance of introducing people to our underwater world. But Mr. Packard also founded our partner organization, the Monterey Bay Aquarium Research Institute, or MBARI for short, with one really powerful goal: to put scientists and engineers together under one roof, building the tools needed for groundbreaking ocean science. Which is why, for the past 30 years, our partners at M4Y have used the Monterey Bay as their laboratory. Now, this is actually a strategic location where the deep sea lies very close to shore, so it's more accessible for our researchers. But let me get you all situated. Here at the bottom, we're in Monterey, and up on the top of the bay, that's Santa Cruz. And right in the middle is Moss Landing and M4Y. But what you might not see lies far beneath the surface. Because in the center of our bay is the Monterey Submarine Canyon, which is actually just as wide and deeper than the Grand Canyon itself. This is the only deep sea testing site in the world close enough to shore for researchers to continuously monitor the movement of carbon into the deep ocean. That's why the partners at M4Y set up shop so close to this canyon. They're able to test tools, run experiments, and of course, be home in time for dinner. But since they're using the bay as their office, that means that their research vessels, like the Western Flyer, is the desk. And the most important office supply is the dock rickets. This is an ROV, or remotely operated vehicle. Now, with no captain on board, this submarine is controlled by pilots on the ship above. And a fiber optic tether helps send power and commands deep down to the ROV, which will then transmit high-quality video back up to the control room on the ship. Robots, they offer many key advantages over the human-occupied subs of the past. For starters, they don't get tired, so they stay underwater a lot longer than we can. And even though our eyes are great, they can't exactly zoom in and take high-quality footage that can later be shared with people all over the world. ROVs are giving us a glimpse in the unique community of weird and wonderful creatures that live in the Monterey Submarine Canyon, many of which had never been seen before we started to use this technology. However, ROVs have also allowed us to learn more about creatures that were discovered a long time ago. Like this fish, the barrel eye. First discovered in the 1930s when scientists brought it up with a net they could drag through the deep ocean. But in those early days, the barrel eye were damaged during collection, and it wasn't until 2008 when researchers made an even more shocking discovery. You see, the barrel eye has a clear gelatinous dome that covers its eyes, which are these green things up here. These might look like eyes, but they're actually nostrils. Don't worry, the barrel eye isn't the only one with some interesting anatomy. I'd like you to meet the vampire squid. Named for its blood-red skin and cloak-like arms, this unusual animal is about the size of a football, but has some interesting tricks up its sleeve. Because when threatened, the vampire squid will turn itself inside out. Now, it looks less like a tasty calamari and more like a stinging jelly. Researchers have found the vampire squid's diet is mainly this white stuff in the water. That's marine snow. But don't be fooled by that name, because marine snow is actually made of decomposing bodies, different pieces of reproductive material, and most importantly, poop. Yeah, remember that the next time you get a mouthful of seawater, okay? But my favorite animal of the deep is the giant larvation, which is giant compared to other larvaceans, but really measures in at about 4 inches long. Like the vampire squid, the larvation is also eating that delicious marine snow. But it does so by filtering vast amounts of nutrient-rich seawater through this complex structure it builds out of its own mucus. These house-like mucus bubbles stretch about 3 feet across. The larvation beats its tail from within this filter home, and the current created actually funnels that food right into the animal's mouth. When threatened, that larvation will simply drop that mucus, swimming away to repeat that process all over again. However, that mucus net will drift down and provide food to other creatures of the deep. Now, until recently, it was completely impossible to study these delicate mucus structures in the deep. But our partners at M4Y invented a new tool, the Deep PIV. This is a laser-based tool mounted to the ROV, which can create 3D models or measure how currents move within this filter home. Our scientists have found the larvation can filter about 20 gallons of seawater through this mucus house every hour. So it would only take 2 hours for a 4-inch long animal to fill up your entire bathtub with seawater. Now, ROVs, they've allowed us to learn how animals of the deep are eating, but also how they're reproducing. Scientists were stunned to come upon this female black-eyed squid carrying this massive egg case in her arms. She carries these eggs for 6 to 9 months until they hatch, but since they take up all her arms and block her mouth, she doesn't eat that entire time. However, the award for the best deep-sea mom should probably go to this octopus. Our scientists found that female deep-sea octopus tending to some recently laid eggs. Octopus will brood their eggs to protect them from predators until we hatch, and they assume that they rarely, if ever, leave them unattended, not even a hunt for food. So researchers checked back on that octopus, week after week, after month, after year, until 4.5 years later, they returned and found 160 empty egg cases. And luckily, some of her babies. They were in awe. 4.5 years, that's the longest recorded period of any animal caring for their eggs. But again, we're studying more than cool animals, because deep sea geography, it's just as important. The ability to map the mountains, valleys, and canyons of the world's oceans, it's been limited in the past, due to the fact that jobs been done from the surface, sometimes even miles away from areas researchers are mapping. So, our partners at M4Y invented this self-guided robot that can actually fly programmed missions close to the underwater terrain and then produce maps that are just as detailed as satellite images of land. But that led to the question, how can life even survive on the seafloor? It looks like a desert to our eyes. So then, they invented the benthic rover. Benthic meaning bottom. Now this robot, it's about the size of a small car. And it could be programmed to patrol the muddy seafloor for up to 6 months at a time. Slowly moving along, analyzing the life of plants. After 6 months, the rover is retrieved to collect data and prepare it for its next deployment. Researchers are constantly inventing and improving the tools we have available to help us answer questions about the sea. By developing and deploying these tools, they are giving us an unprecedented ability to understand ocean health. And all those collective findings, they point in one direction. We are living in an age of a rapidly changing ocean. The ocean, it acts like a sponge, soaking up carbon pollution generated when we burn coal or gas to make energy. Absorbing this pollution, it changes the ocean's chemistry, and it makes it more acidic. This has drastic effects on marine life, especially the phytoplankton we saw earlier, those ones shielding us from the worst impacts of climate change. So, once again, our partners at M4Y brought engineers and scientists together, this time to determine how the phytoplankton would fare in these rapidly changing seas. And as you might have guessed, they needed one more tool. One that can span across the ocean and collect data for years on end. So they invented this robotic float. It drifts across the sea, equipped with sensors that can track ocean health, and it's programmed to dive into the deep sea to collect that data all along the way. Once that robot resurfaces, it will then transmit the data out to a satellite, so it can become freely available to people all over the world. In fact, educators can adopt a float and let their students participate in this groundbreaking ocean science. Researchers use this data to determine how ocean acidification and climate change impact ocean health today and the health of the ocean in the future. But one thing, it's already clear. The ocean needs you just as much as you need it. The ocean, it's the heart of our climate system. It's our best defense against climate change. So it's up to us to protect it. But what can we do? Most of us can't exactly run home today and install new solar panels, buy a brand new electric vehicle, and change our entire diet. Those changes, they're not just intimidating, but they can feel impossible. However, we all can look at what we're already doing, understand how we impact the world around us. Starting with things we already know, we can take our next step in a new direction. Going vegan? Maybe that's too much. But maybe invite your friends over for Meatless Mondays. And an electric car is a huge investment I can't make, but I'm always looking for friends to carpool. But most importantly, share your own ideas and your passions within your own circles. Because your actions and your voices, that is what you'll leave behind as your legacy. And who wouldn't want to add saving the ocean to theirs? Now folks, you have seen some incredible animals and research tools, and if you have any questions at all, again, my name is Jamie Marie. Come on up after the program. I'm more than happy to chat. But if you're ready to get out there and keep exploring, thank you for joining me for Mysteries of the Deep, and have a great rest of your day at the Monterey Bay Aquarium.
Hey, Scuffle, looks like we have some fresh news. Some news? Welcome aboard. Why, these folks look fit as a fiddle, ready to face whatever danger.
Oh, where's David?